Okay, so we're still working on derivatives, and the idea is that we don't really want to have to take a limit every time we want to find the derivative of a function. So the next section that we're going to talk about are the product and quotient rules. So before we go over what the product and quotient rules are, let's remember what we're doing. The idea behind this is that we're trying to find f prime of x, or dy dx, or df dx. They're all the same thing. They just mean the derivative of your function. Here we call it y. Sometimes you'll have the function as y equals something in terms of x, but we're just finding the derivative. We want to find these, but we don't want to take a limit. So let me recall the derivatives that we know how to take. We know how to take the derivative of x to a power n. That's nx to the n minus 1. So we know that one. That's our first one. We also know that the derivative of a constant times a function is the constant times the derivative of that function. We also had the sum rule. So the derivative of f of x plus g of x is the derivative of f plus the derivative of g. And then lastly, we had that the derivative of e to the x was just e to the x. So at this point, those are the 4 derivatives that we know how to do. The question is, how do you find the derivative of something like x squared times 3x to the 4th plus 5x minus 2? Well, this is a product of 2 functions. You can see it's x squared times the 3x to the 4th plus 5x minus 2. So as soon as you say times in terms of x, so this is x squared times something, that tells you this is a product. So that leads us into the product rule, which we're not going to prove this, but it says the derivative of a function u times a function v is going to be u prime v plus u v prime. We're going to write it this way. You could write it in terms of f and g, but I think this is the easiest to memorize. So the derivative of u times v, so a function times another function, is the derivative of the first times the second plus the first times the derivative of the second. So using this rule, let's figure out the derivative of x squared times 3x to the 4th plus 5x minus 2. So again, we're trying to find the derivative of x squared times 3x to the 4th plus 5x minus 2. What you want to first do is I'm going to write out my u and my v. Actually, maybe I'm going to write them over here so we have plenty of room. So u is the first function, that's x squared. V is your second function, so that's 3x to the 4th plus 5x minus 2. Now I need to figure out what is u prime and what is v prime. So that is, what's the derivative of u? Using your power rule, that's just going to be 2x. So bring down your 2, subtract 1. Now what's the derivative of v? Well, here I have a sum and also power, so I'll have 12x to the 3rd plus 5. So if you're confused on how I got this v prime, go back to finding the derivative of a polynomial. Now to find the derivative, all I do is plug it into my formula. So it was u prime v, u prime times v. So in my head I'm thinking u prime v plus u v prime. So u is x squared, v prime is 12x cubed plus 5. So that would be my derivative. You could simplify it if you want to, collect like terms, or we could just leave it as it is. It's actually easier to see the u prime and v here if you leave it as is. So that's an example of the product rule. Let's do another example. Let's say I want to find the derivative of e to the x times square root of x minus 3x to the 5th. Okay, So say the function out loud. It's e to the x times square root of x minus 3x to the fifth. As soon as you hear the word times, that means it's a product. So I'm going to let u be my first function, v be the second. U here is just e to the x. Now my second function is the square root of x minus 3x to the fifth. So if you recall, I told you, try to write everything as a power. So I'm going to write this as x to the 1/2 minus 3x to the fifth. Now let me find my u prime and my v prime. So the derivative of e to the x, just e to the x. The derivative of x to the 1/2 minus 3x to the fifth, well, that's just using the power rule. So 1/2 x to the minus 1/2, then minus 15 x to the fourth. Okay, so I have my u, v, u prime, v prime. That tells me that the derivative is u prime v plus u v prime. So there's my derivative. So all I'm doing is, when I have a product, I'm just breaking it up. I'm breaking it up as u and v, and I'm finding the derivative that way. Okay, let's try one more here. Let's say that I want to find the derivative of x squared e to the x, x cubed minus 2x. So this is x squared times e to the x times x cubed minus 2x. As soon as you hear the word times, that leads you to think of product rule. So there are a couple different ways you could break this up. I'm going to break it up as x squared e to the x is my first function, and then my second function is x cubed minus 2x. Now I need to find u prime and I need to find v prime. Let's start with v prime. That one's going to be a little bit easier. Using the power rule, I get 3x minus 2. Sorry, 3x squared minus 2. Now what about u prime? This is looking for the derivative of x squared times e to the x. This is another product. So to find the derivative, I'm going to kind of do this below here, of x squared e to the x, I need to use the product rule again. So this is actually a product inside of a product. So I'll let, let's say, p the x squared and q be e to the x. The derivative of x squared is just 2x. The derivative of e to the x is e to the x. So that tells me that the derivative here is going to be, well, I don't have a u anymore, I have q. So it's going to be q prime, or sorry, p prime q plus p q prime. So remember, this is kind of like my u, and here's my v, so u prime v plus u v prime. So that tells me that u prime up here is 2x e to the x plus x squared e to the x. So to find the derivative of u, I had to use the product rule again, which tells me that overall now that I've found these four, I just plug it in. So u prime, and I'm going to be careful with parentheses here, u prime v plus u v prime. So I used the product rule because it was x squared e to the x times x cubed minus 2x, so I broke it up. Now this is not the only way you could have broken it up, but this is how I broke it up. But then to find u prime, I needed to use the product rule again. So once you find these four functions, you're done. Now finding the derivative of each one might require a different rule, but finding those four functions, I plugged it in and I found the derivative using the product rule. So that's the product rule. Next question is, how do you find the derivative of something like x cubed minus 5x squared over 2x minus 3? So this function, x cubed minus 5x squared divided by 2x minus 3. As soon as you say the word divided by, where it's a function over a function, that's a quotient. That leads us to our quotient rule, which says the derivative, and we're going to use u's and v's again, is u prime v minus, this time, u v prime all over v squared. So I have my product rule, I have my quotient rule. One thing to notice is that the numerator of the quotient rule is very similar to the product rule, only have a minus instead of a plus, but that's the quotient rule. So this is something that you're definitely going to want to memorize. So my example that we were doing was x cubed minus 5x squared over 2x minus 3. I'm going to do the same thing I was doing for the product rule. I'm going to have a u and a v. So the u is the top, v is the bottom. Then I find my u prime and my v prime. So using the power rule, I have u prime is 3x squared minus 10x, and v prime is just 2. Now I plug this in. So the derivative of my original function is going to be u prime v, and I'll write this up here just so we can be thinking it, u prime v minus u v prime over v squared. So u prime v minus u v prime all over v squared. So there's my derivative. So all I did was break this up as a u and a v, find the two derivatives, plug it into my quotient rule. Let's try another one. How about the derivative of e to the x over 5x to the fourth minus 3x squared plus 6. So I want the derivative of this example. So if we say this function out loud, e to the x divided by 5x to the fourth minus 3x squared plus 6, you can see that's a quotient. So I'm going to let u be the top, I'm going to let v be the bottom. Now I find u prime, so the derivative of e to the x, that's just e to the x. The derivative of this polynomial using the power rule, I'll get 20x cubed minus 6x. And now I just plug it into my formula for the quotient. So this derivative is u prime v minus u v prime all over v squared. So there's my derivative. So let's do one more here. Let's let v of x be e to the x times 2x cubed minus 4x over 5x cubed minus 2x plus 4. And I want to find f prime of x. So this is the same thing that we've been doing. I gave you a function and now we're looking for the derivative of it. So I'm looking for the derivative of e to the x times 2x cubed minus 4x all divided by another function. So I'm going to have to use the quotient rule. I'm going to let u be the numerator, so e to the x 2x cubed minus 4x. I'm going to let v be the denominator, so 5x cubed minus 2x plus 4. I need to find u prime and I need to find v prime. So v prime, I'm going to find the derivative of v using the power rule, so that's 15x squared minus 2. Now about u prime. U prime is the derivative of e to the x times another function. So remember, whenever you say times here, I'm going to have to use a product. So I'll have kind of another u and v. So here the u was e to the x, v was 2x cubed minus 4x. V prime e to the x, u prime e to the x, v prime 6x squared minus 4. Which tells me that u prime here is going to be u prime v, I know we have different u's here, plus u v prime. So I'm going to write this up here for u prime. So what do we write? We wrote e to the x times 2x cubed minus 4x plus e to the x times 6x squared minus 4. So I had my original u, I had my original v. Finding the derivative of v was pretty easy, just use your power rule. Finding the derivative of u, though, that required us to use a product rule. So this is a product rule inside of a quotient. Using these, I can now find f prime. So remember, f prime was using a quotient, so it's u prime. See if I can fit all this in here. U prime v minus u v prime, and then the whole thing divided by v squared. So that would be my derivative of f. So what you want to do whenever you're finding the derivatives of products and quotients is write out your u and v. If you're using then find the derivative of each one. Now you might have to use a quotient or a product rule to find the u prime and v prime, but once you find these, plug it into either the product rule or the quotient rule depending on your original function. So once you do those, you'll be able to find the derivatives of products and quotients.